Hi everyone. Have you ever looked at a number and wondered how far apart the ones are inside its binary representation? Today, we are solving the binary gap problem from LeetCode, a clean bit manipulation problem that's perfect for interviews and daily challenges. By the end of this video, you will understand the idea, the optimization, and how to implement it step by step. Let's understand the problem first. We are given a positive integer n, and we need to find and return the longest distance between any two adjacent ones in the binary representation of n. If there is no two adjacent ones, return 0. So, your task is to find the maximum distance between two consecutive ones in the binary representation of n. And if there are fewer than two ones, the answer is simply 0. For example, if we have n equal to 22, so 22 in the binary representation equals 10110. So if we scan this binary representation from right to left, the distance between the first two consecutive ones in the second and third place is 1, while the distance between the second one and the last one is 2. So the maximum distance between consecutive ones in this case is 2. A naive way to solve this would be to convert the number to a binary string, then scan the string and measure the distance between ones. But this approach is unnecessary. We don't need extra memory, and we don't need strings at all. Instead, we can solve this efficiently using bit manipulation. Here is the key insight. We can inspect the binary representation one bit at a time. So if we have number n, then by using the AND operation like n and 1, this will check if the current bit is 1 or not. And by using the other trick or bit manipulation operation, which is shift right, we can shift the number to the right and move to the next bit. Now, let's talk about the optimized strategy. We only need three things. First, a variable to store the maximum gap between any two consecutive ones. Second, a variable to store the current index while processing the number from right to left. And third, a variable to store the last seen one index. We will loop on the n number while it's not 0. And if the current from right to left, and if the current bit is 1, and we have already seen another one before, then we will update the gap answer. Then we will set the last index to the last seen set bit or 1. So let's move to the code. I'll define three variables: int gap and current index. and last variable called last, and I'll set it to -1. The gap will store the maximum gap between two consecutive ones. The current index is used while processing the number from right to left, and the last index will hold the index of the last seen one. So I will iterate while n is greater than or equal to 0, and check if the current bit is 1 or not. If it is 1, and we have seen another one before, I check for that by that condition if the last not equal -1, because the last is the variable that will track the last set bit. Then I'll update the gap to be the maximum between the current gap and the distance from current index minus last. The current index is the index is used to process the number from left to right, and the last is the index that point to the last seen one. So this subtraction will give us the distance between two consecutive ones. Then I'll update the last to the current index to prepare it for the next processing. Then I'll shift my n number to the right by 1 bit to examine the next bit, and I'll update my current index by incrementing it by 1. And finally, I'll return the gap. Let's run it to check for any compilation errors. And as you can see, all the test cases pass. So let's submit it. And here we go. This solution runs in a constant time and uses a constant space. So it's efficient, clean, and interview ready. And that is how you solve the binary gap problem using bit manipulation. If you enjoyed this explanation, hit the like button, subscribe for more coding breakdowns, and let me know in the comments which lead code problem you want next. Happy coding, and I'll see you in next video. Bye.